So welcome to this video. We're going to work through this slide that's from the resolution of vectors on Blackboard. This is the elbow joint, the radius, the humerus, and here is a representative muscle representing basically all of our elbow flexors. And it is the force of this muscle force is acting at 60 degrees from the horizontal. Okay, so now this force can be resolved into its vertical component, or which is the rotary component. So this force times this moment arm, which is perpendicular, will cause a flexor torque. And it can also be resolved into a horizontal component, which we call the stabilizing force, which basically supports this elbow joint. Okay, so rotary component, stabilizing component. So I'll just put in rotary, stabilizing. Okay, to visualize how you calculate this R, you may have to do some manipulation. So here's our force, our 650 Newton force. Here's our H. And here's our vertical force. Okay, and so if you want to view it as solving for this R, this is this force right here, the R force, and the stabilizing force. So it becomes another triangle. So this is a right angle, 90 degrees. 60 minus 90 is 30. So this angle is 30, and this angle becomes 60. So this is just a different way of actually solving for this rotary component. And so the angle opposite of this rotary component is 60. So you can get sine 60 equals V, or in this case R, divided by 650 newtons. You solve for, we'll say R in this case, R, and then R is 562.9 newtons. The only thing I did was, if it's hard for you to visualize this vertical force as a rotary force, I just created the triangle that allows you to solve for the R here. In reality, this V, solving for this V, is the same as solving for this R. Okay, and then to solve for the stabilizing force, which is the H, but we'll call it an S, cosine of 60 is H over 650 newtons. You do the math and you come out with 325 newtons. So again, sometimes you have to manipulate these triangles to kind of figure out the right triangle that you can create to solve for the forces that you want to solve for.